allowed and should think of infinities inside boundaries. Now, we have a little circle here. Now, this circle could be a sphere in 3D, so, you know, don't get stuck on the 2D thing. But it could be a sphere. And the triangle in the middle is an equilateral triangle, and it could be a tetrahedron in 3D. So it could be a tetrahedron inside a sphere. Now, since everything in the universe has spin angular momentum, everything in the universe is polarized. It has a positive, negative. It has a north and south pole. And so since things are polarized, you can add another reverse triangle to that triangle. Interestingly, right away you get one of the most ancient symbols you find all around the world in most of the cultures. And that, you know, that is part of the conversation I'm going to have on Sunday about ancient civilization that I won't have time to do tonight. So this can be continued. That is, you can continue to add triangles. And if you add triangles, you get the same geometry again, but in a smaller scale. So we call that in fractal lingo resolution scale, right? So different resolution. So now you can continue to add further triangles, and now you get the same geometry again at a different scale or at a different resolution. And every time you add a new resolution, you're defining a new boundary. Now you see? So now you have smaller boundaries and smaller boundaries again. You can continue to divide the space. Now, it's only in that one. I didn't do it all around, you know, got lazy. But, you know, you could do that again and again. See, it's dividing right now, but you can't see it. And it's making boundaries. And now I could give that program to my computer and run it and get the computer to zoom in every 5 resolution, for instance, and then keep making triangles and zoom in and keep making triangles and zoom in, and it would continue to do that to infinity, meaning, well, as long as it's got power and, you know, the chips are running, it would continue to divide space. However, there is never a time that I would exceed that first boundary I have set for myself. Right? I would never exceed that first boundary. That first sphere I define would contain all of the divisions of space from there on. That is profound, really. It really is. It's profound in terms of physics, but that gets more complicated. But as well, it's profound in terms of philosophy. And I think, really, part of the reason why ancient civilization had geometry in their Morses and in their traditions and so on is because they were trying to convey that very concept. That concept that infinities are part of the boundary of your existence. That is, viewed from this perspective, everything can be divided to infinity. Okay? And, well, if physics communities understood this, first of all, right away, they would alter their accelerators projects. Meaning, currently, you know, we thought, when we discovered the cells, we thought the cells were the smallest thing. And then we discovered the atom, and then we thought, oh my God, that's so small? You know, there's billions of atoms in every cell. That's got to be the smallest thing. And then they discovered the electron, and then they discovered the protons, and then the quarks. Every time they go, oh my God, that's got to be fundamental. That can't be anything smaller, right? And now we're trying to find the Higgs boson. I mean, the accelerator has to get bigger every time, all right? And so now the accelerator, which is pretty well the biggest accelerator we ever be able to build, and that means that we've reached the end of our capacity to go smaller, okay, is the Hadron Collider that's being built in Switzerland. It's miles long. It costs $300 billion, 5 countries had to get together to pay for the bill. And now we're looking for the hadron, which is like billions of times smaller than an atom. What are we doing? We're dividing the space. I mean, we're dividing space at that point, no doubt. And guess what? You can keep dividing, right? We did the same thing in the other direction. We thought our planet was the biggest thing in the universe. And then we thought we found the solar system. Oh my God. And then we found the galaxy. And then we thought we were the only galaxy. And then we found all these other galaxies, and we found superclusters of galaxies. And then, and then universe. And now we think the universe is the biggest thing. Guess what? That universe could be embedded in a larger one, in a larger one, in a larger one, and so on. So, instead of looking for a fundamental particle or looking for a fundamental universe, maybe we should start looking, and that's what I did at that time, for a fundamental pattern of creation, a fundamental pattern of division that define creation. So, in my day-long seminar, I'll be able to show you scaling mapping that we did with observation and equations we wrote that shows that, dimensions are actually, concentric to each other, but as well that the division of space undergoes very specific relationships to each other that defines the geometry of space, that defines how space divides and what scale gets produced at which level. It's not a random thing. And so that is the key, because if we forget the fundamental particle, if we understand the fundamental division of creation, if we understand the fundamental geometry of creation, now we have the key to some of the most powerful information one can have in the universe. The foundation of creation. Okay? Interestingly, if you look at various traditions, Kabbalistic, Hindu tradition, all these traditions talk about geometry being fundamental to the structure of creation, and if we could decode it, we would have this power. What it means to you right now, though, is that instead of thinking of dimensions as planes overlaying each other, and things like that, is that to think of yourself as an infinite potential in every single atom that you're made of. Right? Like really to sink that into your being, to really connect with that possibility that within you is the infinite potential of the curvature of space-time. I mean, it's all curved into singularity in each of your atoms. And that you absolutely are justified in a non-spiritual way, in a philosophical way, to call yourself an infinite potential, an infinite being. Just mechanically. Just by the fact that you can be divided to infinity. And all of these things are happening in a really, really cool way, because they all collaborating. All these little infinities, they all got together, billions of them, and they made you. And they all agreeing, we do that, you do that, And that's an amazing thing, just to give you an idea of the potential information transfer that you represent. Your little thing, singularity, relative to the universe, you look very, very small, right? But in your DNA, if I took the DNA in your body, right, and I put it end to end, so I take there's about, I can't remember how much, I made the calculation, but it was a while ago, per cell, but there's about 100 trillion cells in the body. And I took the DNA and I stretched it out in each cell, and then I put it end to end, and calculate how long that is. You could wrap it around the world 5 million times. 5 million times you can take your DNA that's in you right now and wrap it around the world, okay?